No, because it
Oh
says
my god.
it says it's still connecting. Okay, I can go live now. It's going live. It should be going live. But even if it does go live, the Kahoot's gonna be loading. Okay, it's good now. We're good now.
Sure about that?
Yes, it says we're live.
Are you live?
I am positive that we're good now. Can you hear the Kahoot music?
Okay, yeah. No, I just see a white screen.
Yeah, I see a white tab.
Well, that's lag, okay?
Yeah, I just see a white screen.
Did you pin the link into?
No, you
Dang.
can do that.
Oh, wait.
You can do that.
Wait. There it is. I see it now, but it's like still just spinning. It's okay. Yeah, okay.
It's fine. It's fine.
No, I don't want to copy the message link. I want to copy the link.
No, you don't.
Wait, do I have to do it on the Study Bubbly account because I'm online person?
Well, if you want to pin it, I can pin it. I can pin it.
I have no clue.
All right. Oh, you can just. Well, no, I think you need to post on the own account.
Oh.
All right.
Please remove any web addresses.
All right. Y'all, hello. Okay. All right. So, I'm trying to reload the stream on my computer and it's not loading, so I can't check for you. Y'all have to do it.
Check what?
I can't check the stream for you guys.
Your stream looks fine on my end. I just can't post the link in the chat, so I guess I'll have to switch to the Study Bubbly again.
All right. Well, I guess we'll start in the meanwhile because my computer's just. I'm gonna cry at this point.
There we go. We have pinned the link to the Kahoot, so if you guys want to join us and want to torture yourselves for some reason that's beyond me, you can go ahead and click it.
You're very encouraging, Dove. That's all I'm gonna say. Very encouraging.
We always want to be encouraging.
You're
in
right.
a physics live stream.
Guys, this is the last live stream, so be excited for it. All right.
No,
all right.
How can anyone be excited for physics?
I don't know, man. I don't know. But for all you joining, click that link inside the pins. Dove didn't pin the website, but that's fine.
It is pinned. Wait, website?
Yeah,
the website's in the description.
The website is in the description, yeah.
Okay, yeah. You can go to the description and click it. That's fine. All right, we can start the game now. Whoa. Whoa. All right. So, first question. Ding, I hope you have the sheet up because I don't see you in the sheet. All right, which is the correct answer?
Sure.
I love how he gave 30 seconds for this. Okay, so 2 objects released on the top of the ramp. One of them rolls down and one of them slides down. So, which one will reach the bottom first? Okay. I love how you guys just went. Okay. Thanks, Day. Okay. Sometimes. So the block, it's D. Because it doesn't gain rotational kinetic energy, but the sphere does. So, you remember kinetic energy, right? Okay, thanks, Ding. Thanks, stuff. I'm asking you guys.
Who are you asking?
I'm asking you guys. You're the only ones who I can talk to.
Well, for all I know, that could be an open-ended question, but yeah.
Anyways, continue on.
Okay, so rotational kinetic energy, we kind of did it. I'm not sure if we exactly did. Yeah, we did it, I think. Anyways, rotational kinetic energy, or angular kinetic energy, is kinetic energy due to rotational object and part of its total kinetic energy. So, due to having the rotational kinetic energy, the sphere. Wait, what? The block will reach it first. Well, that was definitely clear. That explanation was 100% spot on perfect, right? Guys.
I don't know what to say. You kind of just explained it, but
All
yeah.
right, all right.
So it's definitely not C because the question mentioned that there is no friction. It's not B because there is no torque, and it's not A because rotational kinetic energy actually slows down the sphere in comparison to the block.
Yeah. For torque, it doesn't really have to do with that. Yes, but actually no. Definitely great. It's definitely
We'll get
great.
to torque when we get to torque.
We'll get to there someday. All right. Which is the correct answer again? Whoa.
Are you still there? Oh,
Yes.
I thought you died because the stream was like frozen for me.
Sometimes. Okay, so
Our next
what's
question.
your favorite type of problem? Okay, block A and block B.
Read it?
No.
Wait.
So,
yeah,
determine the mass of block B when it's released from rest. And yeah. All right. Definitely read the question, right?
You didn't read the entire question.
It's fine. It's fine. So it's measuring the time block A takes to reach the floor, and the students must take which of the following measurements to determine the mass of block B. So the answer, I'm gonna zoom out. The answer is C, which is only the mass of block A and the distance A falls to reach the floor. So this has to do with a lot of physics stuff. Just kidding. So you can use different ways to solve this, but mostly this part is kinematics. So I was thinking of I don't know. Well, you need other stuff to solve it if you solve it for like potential energy and kinetic energy stuff, but you don't have that. So for kinetic energy, kinetic energy. I didn't say the same thing 5 times in a row. Don't worry. But there's 5 main equations for kinetic energy. So those 5 equations are really important, and it's best to memorize them. But using that, once you know the distance and once you know the mass, you can find the mass of the other block. This is using the equations. Guys, I love how you're so interactive with what I'm saying. Hello? Okay.
Were we supposed to like interrupt you when you're explaining?
Yeah, you're
yes.
in the middle of explaining.
Okay, alright, guys, alright. But yeah.
Well, I mean, couldn't they use like F equals ma? Because if they're like measuring the time block A takes to reach the floor, and then choice C says the mass of block A and the distance block A falls to reach the floor. So if you get the time of the distance, you can find the acceleration, and then you can just use F equals ma in the y direction. Find the mass of block B.
I think so. Because there's force of...
Correct me if I'm wrong.
Because there's... I think you're right, but there's force of both. There's force of tension, right? Force of gravity, and that's what's causing the system to move. The blocks to move. But yeah. All right, moving on then. Do one of you want to do this one? Okay, guess not.
Give us some time to respond. I need to pull it up on the thing because like your thing is lagging.
Thank you. What is the tension of the string pulling the cart?
Yes, a lovely card.
Very peaceful music. This one's similar to the one that we just did.
It's a pulley pearl.
All right. It's great.
Did you type in an O instead of a 0 for the diamond answer?
We're not going to worry about that. It's fine.
Just made my day.
All right. So, yep. First,
So hold on. I'm not looking at the right thing.
ding. Okay. So yeah, first is finding the weight. Because once you find a weight, you can find the normal force. And then use what Duff said, acceleration equals net force divided by mass. And once you get the acceleration... Okay, yeah. I'm getting every question wrong because I don't want to give you the answers, but it's fine. So once you have the acceleration... What? Dove?
No, I'm just laughing.
Okay,
What?
alright.
What?
Am I lagging? Alright, it's fine.
I don't know.
Alright, it's fine. So once you know the acceleration, you can find the tension by... Yeah, once you find the acceleration, you can find tension. So first finding the weight 1 and weight 2. So the cart 1 or M1, weight equals mass times gravity. So that's 4.9. And then the weight for the second one, M2, would be 0.980 or 0.98. Yeah, and once you get that, you can find net force equals weight. Are you following me, or did I lose you there? Because I'm pretty sure I lost you there.
Are you asking us?
Yes, I'm asking you.
Yeah, I'm following. Sure.
Duff, All right. Okay, Duff. But you know how there's tension in the system, right? So there's tension in the system, and then the system's moving due to that tension and the gravity from the second suspended mass. So, okay, thanks for being responsive to whatever I'm saying.
Well, what else am I supposed to say? You're
Good question. I don't know, but it seems like I'm only talking and I'm gonna die. That's fine. It's fine. All right, so yeah, the answer is 0.816 to the right, because I am dying throughout this whole time. But it's tension pulling the cart, so it's asking for M1's tension. So take note of that. Shall we move on, or?
Or else we might not finish in time. Actually, will we finish in time? That is a very good question.
I don't know. Okay. All right. Find acceleration of 2 cars hooked together by rope as the car in front with a mass of 3 kilograms It's pulled up a slope of 37 degrees from the horizontal with a force of 30 newtons, and the car in the back is 1 kilogram. So let's draw this out. Y'all should remember this because it's kinematics. Ding and dove.
That was a while ago.
Okay, alright. Where's my calculator? Oh, here it is. Okay, found it. Alright, alright. And yeah, the time is really short, but that's kind of similar to on a test, so it's fine.
It's not me, but it just be like that sometimes.
Okay, so this problem is similar because the two cars are hooked together. So first you need to find the first car's okay, time runs up. Time ran out. So first thing is you need to find the acceleration of the first car. And due to the tension, the acceleration of the second car can be calculated from that. So yep, that's basically it. And if you don't have enough time, feel free to pause the live stream and do it. So the answer is 2.8 meters per second squared. All right, what's the magnitude of the net force on the potato? So a person stands in an elevator weighing a potato. The mass of the potato is 0.15 kilograms. Scale reads 1.14 newtons. We gave so much time for this one, right?
Problem.
What did you say?
The potato problem.
Yes, the potato problem. So, all right. So the answer for this one is negative 0.33. And, yeah. So, all right. So you know the mass of the potato and you know the final weight that it has. So from that, you can find the net force on the potato due to acceleration, that sort. We love how we have so much time to solve these problems, don't we? All right.
Better to have more time than not enough time.
It's fine, it's fine, it's fine. All right, number 6, which is the correct answer. Can of paint.
Very intuitive.
Can of paint with a mass of 6 kilograms hangs from a rope. If the can's pulled up to a rooftop with an acceleration of 1 meters per second squared, what is the tension in the rope? You'll have to see it. You'll have to see it. All right, we're gonna ignore how on the sheet that one's missing. We're gonna ignore that. Don't know why that's missing.
They don't need to know.
It's fine. It's fine. It's fine. It's completely fine. Okay, but what you need to know for this one is, first find the force of tension that's being pulled up, and then find the acceleration due to gravity that's going down. And once you solve that, you get 66 newtons. So, yep. Oh, wait, no, did I say tension going up? Find the force going up, and then find the force due to gravity, and then you can solve for that. So, yep. Moving on. Whose question is this now? Guys.
It's the circular motion.
Yeah, but who made this question?
Oh, I did.
Okay.
Oh, no.
All right. Your turn, Dove.
Alright. So it says object. Wait, is this the right question? An object moves at a constant
Yeah.
speed in a circular path. Which of the following statements are true? Select two answers. I don't know how much time we gave for this one.
We didn't give much time. We didn't give much time for
Is
all
it
of any
up?
of them. Yes, time is up.
Alright, so based on what we know on what's it called again? Uniform circular motion.
Yes. Yes.
So we know that the velocity is changing because even if you're like traveling at a constant speed, since your direction is changing as you're going around in a circle, your velocity is going to change. Whoa. And the magnitude of acceleration is constant because if you're like traveling at a constant, well,
Right.
I'm like losing my words. I'm like
You're fine. You're fine.
your acceleration is going to be constant because like your velocity isn't what's the word?
Constant?
Y'all aren't gonna help me. Yeah. Yeah. there we go.
Okay, all right. So yeah, so answer is triangle and circle. Velocity is changing and magnitude of acceleration is constant. Because velocity is constantly changing due to like the constant change in direction, like what I've said. So, all right, moving on. Okay, dang. You haven't said anything in the past.
Dying.
I know
Is
you
physics
are.
problem.
Yeah. So, while driving fast around a sharp right turn, you find yourself pressed against a car door. What is happening? Okay, yeah.
Being pressed against the car door. That is what is happening.
That's right. You're right. So, time's up, and the answer is B. The door is exerting a rightwards force on you. So, if you picked centrifugal force, technically that's not correct. Because if you think about it, centrifugal force is, if you're turning right, centrifugal force is what's make you towards like the center. Correct me if I'm wrong. Right? Okay, thanks. Thanks, guys.
Yeah.
Thanks.
The points towards the center. Well, we are confirming.
Yeah, but after like 3 seconds.
I think that's just your lag, man.
Okay, all right, Dove. But does one of you want to explain it?
Well, I mean, the fact that it says it's a sharp right turn already takes out like why it's not a centrifugal force, because like centrifugal force is mostly applied to uniform circular motions or just circular motions, and this one is obviously not a circular motion because it's a sharp right turn, and like when you're going to do a sharp right turn, the car is turning but you are not, so
Yep.
you're gonna continue to go with because of inertia. That's why you're gonna press up against the right car door, and that's why the door is exerting a rightward force on you, because more Newton's laws.
Yep. All right, so moving on. Okay, next one. Which is the correct answer? At the surface of the Earth, an object with mass m has weight w. If this object is transpired to an altitude that's twice this radius of Earth, then at the new location, what? So yeah, just keep in mind that it's not what you think it is. Dun dun dun.
Aye.
This is not what it is. Everything is a lie.
You're right.
More equation time.
Yep. My computer's completely not loading, so I can't really do anything at this point. It's fine.
You mean it's not?
We shouldn't worry about it. Okay. You have 10 seconds left, everyone. So the answer. Okay, so Okay, time's up. The answer should be D, or 4, or green, or square. Anyways, so basically, the mass won't change due to the location. What changes is the height or the radius of the Earth, right? So when the object's distance from the Earth increases by a it doesn't say, a factor of 2, right? So wait, hold on.
Wait a minute. Shouldn't it be C?
Yeah, it should be C.
Because if you have the equation, which is 3 over r squared, and if the radius doubles, then you have to.
Yeah, you have
I just
to
forgot the word for math.
Square it.
Yeah, square it. Yeah, that's the word.
Yeah, it
and
should
if
be
you square
C.
2, it's 4. So, yeah.
It should be C. Yeah. Don't know why we put D. It's fine. It's fine. We're gonna ignore that.
Yeah, and the reason it's 4, well, 1/4 is because gravitational force is decreased by 1/4 due to radius at the bottom of the fraction.
Right. So on to the next question.
It's inversely proportional.
Yeah. If the stick remains at rest in a horizontal position shown below, what is M? Oh, this is horrible. All right. Uniform meter of stick of 1 kilogram is hanging from a thread attached at the stick's midpoint. One block of mass, 3 kilograms, hangs from the left. Another block, unknown mass M, hangs at the 80 centimeter mark of the stick. Stick remains at rest. What is M? We shall never know. Okay. Whose question is this? Dings?
It's not mine.
Dove? It's yours then.
What's up?
Is this your question?
Maybe not.
Okay, that's very specific.
I am not claiming it as my own.
Okay, all right. Alright, I shouldn't whistle because I probably am lagging and it's just gonna... Okay, so you still have 15 more seconds. Alright, time is up. The answer is B. Dove, do you want to explain it or no?
No.
Okay, great. Thanks so much. Feel absolutely.
You're welcome.
I feel blessed. Alright, so sometimes, just sometimes. Alright, so this is a torque problem. And once you rearrange it, basically it's R1 M1 times G equals R2 M2 times G. So G is gravity. And then once you rearrange it, M2 equals R1 M1 divided by R2. So the first, the radius of the first one is 50 centimeters. Since the other one is 80, so that means the other one's 30. So 50 centimeters times 3 kilograms divided by 30 centimeters equals 5 kilograms. So that's how to solve that one. All right, moving on. I'm glad Metro's with us. That question that we just did is kind of yeah, it's kind of So, all right, moving on. lowest point in the path, tension of a rope is 50 newtons. What is the speed of the bucket? So a 60 centimeter rope tied to the head of a bucket, which is then whirled in a vertical circle. The mass of the bucket is 3 kilograms. Kilograms? Kilograms. All right, Dove, you're up. I'm grateful for the silence, Dove. Amazing. Okay, I guess you're just gonna stay silent. Dove. Dove. Dove has disappeared from the face of the earth. Okay, Ding, you're up. It's just circular motion.
Right, that's like the unit I failed at, but you know, we don't worry about that.
Yeah. Yeah, keep in mind, guys, we're completely not ready for the physics test, but one thing I suggest y'all to do is during the Christmas, just practice over physics. Some physics questions, if you can, because mostly it's just the questions that need practice on. That doesn't make any sense, but we're not going to worry about it. We just need practice more, so, yep. All right, so force of tension minus force of weight. Once you get that, you can calculate the velocity or the speed of the bucket. So it's using the equation of somewhere. Okay, so M is using the equation mv squared divided by r. So, and then you plug in and yeah, so isolate velocity and then plug in, and then you should be good to go. Yeah, we're doing these in a whirl, so just pause if you think it's going too fast. Moving on to the next one then. Which of the following points towards the center of the circle in uniform circular motion? Ding, do you want to do this one now? All right, thanks.
Sure? Oh boy.
All right.
You lagged really badly.
Did I?
I have no clue what you said.
Oh, do you want to do this one?
Which one?
We're on 12.
Which is the following point towards the center of the circle in uniform circular motion? Okay.
Yep. Okay, time's up.
So uniform circular motion again. There you have to think about the net force, which is the only force there is in a uniform circular motion because it's a net force. So in this case, net force
It's fine.
So like usually there's something that keeps the object in the uniform circular motion, whether that be like a string, which in that case would be like tension force or friction force, depending on what you're looking at. So that's why the force that's going towards the center is a net force, and remember it's also accelerating towards the center because in uniform circular motion the velocity is constant, and the only way that there is acceleration while the velocity is constant is if the acceleration is perpendicular to the velocity. So it will be going towards the inner point of the whatever system you have.
Right. That's great. Okay, moving on to the next one. Where is Dove? Okay, great. I think Dove is dead. Dove is just unresponsive. Physics has made her pass out. So, which is the following possible result for a sum of 20 unit and 40 unit vector? Ding, do you want to do this?
Going back to unit 1, yeah. Tell me when time's up.
Yeah. We kind of basically deleted all the other answers for some reason on the sheet, but we're not gonna worry about that.
What?
Don't worry
Wait,
about
is
it.
time up?
No, you have 5 seconds. Yeah, this one's. Okay, time's up.
This is just a simple trigonometry
Okay, wait,
geometry
hold
question.
on. Okay, the answer here says 18 on the sheet. It says 37. We love to see it.
Oh, that's great. Okay.
Good. Yep. You love to see. So yeah. Yeah, I'm typing.
Again, another trigonometry question.
Yeah, I'm typing in my calculator to see which one it is because that's great. It's great. We love to see it. Yeah. So trigonometry, or you can use divide it up.
You have to think about the largest possible range and the smallest possible range that this answer could give. So in this case, it'll be like a 180. It'll be like a linear. How do you say this? A linear, like the two are added up in a linear way.
Yeah.
That would give you the maximum and the minimum distance for the vector. So the sum of 40 and 20 is 6. 0 are also not right, and the only one in between is 3, which is 37.
Yeah, I think we selected the wrong one because I'm pretty sure it's not 18, but it's fine.
Yeah, it's not 18. I don't know why it says 18.
All right, moving on. Next one. Okay, bullet fired, followed. Bullet fired from a rifle begins to fall. When? As soon as it leaves the barrel, after air
This one
friction.
shouldn't be too hard.
It's definitely after air friction reduces its speed.
No, it's exactly 2 seconds after. What are you talking about? That's how guns work.
Right. You're right. All right. So the answer is A. So as soon as it leaves the barrel. Yep, time's up. Okay, are we gonna explain?
Yeah.
Or
Yeah, because like as soon as there's not an external force acting on the bullet, gravity is gonna start pulling the bullet down because gravity is always there. So as soon as it leaves the barrel, which is what keeps the bullet from like going down essentially, it's gonna start going down.
Right. Okay, so that one's that. So moving on. The first few questions are the big.
Oh my god, you're lagging really bad one.
Oh, well, I'm trying, man. Oh, double points. Whoa. Okay.
There's like a 5-second delay.
Okay, select the correct answer choice. One ball is dropped vertically from a window. At the same instant, second ball is thrown horizontally from the same window. Which ball has greater speed at ground level? So, this one's a trick question. Why are some of the questions blank on the sheet? It's fine. So, the thrown ball is the answer. Ding.
Yeah.
You want to explain?
Okay, so the reason why it's the thrown ball is because, oh my god, the freaking lag. Like, your response is like 5 seconds after what I said. Anyways, the thrown ball has the greater speed because the trick to this is because it's asking for speed and not velocity. So speed, as we know, is a scalar quantity, while velocity is a vector quantity. So if it was asking for, say, the highest vertical velocity, then the drop ball and the thrown ball would have the same vertical velocity. But since it's asking for the speed, you have to add up the sum of the two vectors, which is the x and y components of the ball. So in that case, the thrown ball would have a greater speed because it also has a horizontal force in addition to the vertical force.
Right. We love the sirens. All right, so moving on. I don't know where Dove is, to be honest. Dove is just off from the face of this earth. She doesn't exist. All right, So which statements are not valid for projectile? It's the same question, I think. So hold on. Why do we have this question here? It's fine.
What?
We're not gonna worry about it. Okay, so the answer is B and D. So, Ding, I'm not sure if you're. I don't think it's on the sheet. Oh yeah, it's on the sheet. You have to look at the Google Docs. That's why it's not on the sheet, because it's too.
Yeah, I'm on the Google Docs.
It's too big. Okay, so which statements are not valid? So, you can go.
Okay, so let's examine each question, not question, answer choice, because why not? So A says the projectile has the same x velocity at any point on its path. Yes, that will be true because there is no air resistance, so there will be no force slowing down the x velocity, well, the velocity in the x direction. So that would be true. B says the acceleration of the projectile is positive and decreasing when the projectile is positive and decreasing when a projectile is moving upwards. 0 at the top.
Oh my god.
Negative at the projectile.
That is horrible. It's fine. Okay.
So acceleration is, and we know that because gravity is the same. Otherwise, we would be. I don't know.
When you jump up, you slow down. All right. And
that's the only acceleration force, so B is wrong. So C, the y component of the velocity of the projectile is 0 at the highest point of the projectile's path.
That's correct.
This one would also be true.
Yep.
Because parabolas and that sort. I'm not going to go too much into detail, but yeah. And D says the velocity at the highest point is 0. So that's the tricky part, is velocity is a vector quantity. So if it just says the velocity, well, you can also consider the horizontal velocity. And since there is no resistance in the horizontal direction, there's always going to be a horizontal velocity, even if the vertical velocity at the highest point is 0.
Right. Okay. We should move on because I don't know if we're going to finish. We're at 17.
Lovely.
All right. Yeah. You love to see it. Okay. So you're in the middle of a large field. You walk straight line for 100, turn left, walk 100 more in a straight line before stopping. When you stop, you're 100 meters from your starting point. How many degrees did you turn? So this one's...
As long as you, draw out the diagram, you should be fine.
Hold on. Okay, so you walk in a straight line for 100 meters, right? You turn left, walk 100 more meters. Okay, all right. Okay, question. It's fine. Ding, correct me if I'm wrong, but if you walk forward for 100, walk left to 100, if your distance is 100, that means all your angles would be 60, 60, 60, right?
Yeah.
Okay, so how many degrees did you turn? You would need to look at which angle. So starting from where would you consider? Because, yes.
Well, you first walk straight, and then you turn once, and then you turn a second time. So there's only 2 turns.
Wait. You walk straight, right? And you turn left and walk 100. You only walk...
And then you turn left again. And you're back at your center.
Wait.
It's whatever the triangle is called, because my brain's working.
You don't walk back to the center? That's not what it said.
Yeah, when you stop, you're 100 meters away.
Dang.
I'm dumb.
It's fine. That's fine. It's fine.
I can read.
Definitely. All right.
So you walk in a straight line for 100 meters, and then you turn left a X angle.
Right.
For 100 more meters. So, and then you stop. When you stop, you're 100 meters from your starting point, right?
Right. Yeah, so it's a 60, 60, 60 degree. So it depends on what direction you start measuring from. So you can say north of east or something, etc. like that. So if it's north of east, you start at east and go to the north. So since it's going up and going left, We can technically, yeah, we can, yeah, okay. So you can reverse the, you can rearrange, not reverse, rearrange the vectors. So you can go left and go up. The resulting vector would be in the same direction, right, Ding?
Yeah.
Okay, so because of that, it's 60, 60, 60. The answer would be 60 degrees north of east. So counting from east going to the north, it's 60 degrees. So yeah, it really depends on what direction you count from. But okay, should we move on?
Yeah. We're like at 46 minutes, so we might not finish.
Yeah, that's fine. We'll get through as many as we can. So you're riding in a train. Okay, this one's my favorite one. All right, you're riding in a train at 90 miles per hour. If you throw a ball straight up, where will it land? So yeah. Okay, yeah. The next one's also it's one of them that I like, but all right.
Time up.
9 seconds. Okay, this one's your question, right?
Yeah.
Okay, and note that you're inside the train, so.
I mean, you
Yeah,
are
it does-
riding the train,
yeah.
so I would expect you inside the train.
No, you're actually on the tracks. You're not in the train. No. All right. You want to explain?
Yeah. So because you're riding in the train, so you're going at the same speed as the train because the train is carrying you, and therefore when you're holding the ball is also going at the same velocity. So when you throw the
Right.
ball up, assuming that there is no air resistance, it's gonna still travel at the same horizontal velocity.
Right, right.
Which is why when it lands back down, it's still gonna have it's still gonna be traveling at 90 kilometers per hour, and you're also gonna be traveling at 90 kilometers per hour. So it's gonna
Right.
land exactly where you had it,
Yeah.
which is in your hands.
Yeah, it's not like in a train where you throw the ball up and it just like goes backwards and like hits you in the face, but that would be interesting. What if it was a bullet train? You know how fast that would be? All right. You were riding on the back of a train at 90 kilometers per hour. If you throw a ball from the back of the train at 90 kilometers per hour, where will it land? So you're facing the back of the train. You're facing the opposite direction to where the train is going. So, Ding, I don't know if that's on the sheet.
I don't see that question anywhere.
Okay, so that's not on the sheet. It's fine. I'll explain it, I guess. All right, yeah. So technically you're throwing negative 90 kilometers per hour. So the answer would be A, or triangle. So yeah, basically if the train's going 90 kilometers per hour, you're facing away from that, right? You're at the end of the train. So if you throw a ball from the back of the train, like towards the rails, because assuming you're on the back, at 90 kilometers per hour, for you inside the train, like it doesn't matter if you're inside or outside the train, but if you're inside of the train, for you, like you would look and you would see that the ball would travel for you forward, for the train backwards. Ding, you're with me, right?
Yeah.
Okay, yeah. So basically, one thing to note is that for you, it looks like it traveled, but for an observer, from what they see, like when you throw the ball, you're moving backwards, but you're also moving forwards at the same time. So assuming you throw it only with horizontal, and not like, both horizontal and vertical, it will basically land in the spot where you threw it from because the train's moving. So yeah, so the answer is A. All right, moving on to the next one. All right, you push a heavy desk. When do you work on a desk? The answer is D, guys. That's the correct answer. All right, Ding, do you want to?
Okay, yeah. So for this, you need to examine the definition of work and you need to know that work is only done if the object is moving and also in the direction where you apply the force, essentially. So because of this, A is definitely not true, because as long as you're exerting a force, you're doing work. That's not true. It has to be only if it starts moving in the direction that you're pushing it.
Right.
Which means that it is B.
Right. And it's the opposite of C.
C is not true either.
Yeah, it's opposite of C. And D could be a possible choice. Just kidding. Yeah, no. It doesn't do work on you
really
unless...
hard, but you bounce back.
Exactly. All right. 21. When the speed of your car is doubled, by what factor does its kinetic energy increase? So remember your formula for kinetic energy. Do you remember, Dean?
1/2 mv squared.
Okay, yeah. Great. Good you remember that. Alright. Did Dove just die? Or is she just...
I don't know.
Is she just like not responding?
I don't know.
That's sometimes. Just sometimes, you know. Okay, so the answer for this is 4, or C. So if you double the speed of your car, so following the equation, kinetic energy equals 0.5 mv squared. So if you double the velocity, you multiply it by 2. If you use 1/2, it's easier to visualize it. But 1/2 times 2, that would equal to 1. So 1 mv squared.
Wow.
Right? Dang.
Wait. What? No, wait.
Wait.
It's asking for when the speed of your car is double.
Oh.
What is the kinetic energy increase?
Well, we're
So
gonna
if you
ignore.
increase the
Yeah, we're
velocity
gonna
by
ignore
2,
what I said.
it's not cubed. It's, oh my god, I can't remember that word today.
I have no idea what.
To the power of 2.
All right.
Squared.
Yes, squared.
Squared, and 2 squared is 4.
Yeah. Okay.
So kinetic energy increased by 4.
Yeah. All right. So you need to
A
like
factor of 4.
parenthesize it, but yeah. So Ke equals 0.5 m parentheses 2v squared. I didn't put a parentheses and I messed up, but we don't worry about that. But if you compare 1/2 with right, so it's 4 times. Hold on. Right. All right. So yeah, you're comparing the velocity. So it's not 1/2. It's 1 comparing with 4. So it's 4 times. We're doing great, aren't we, Dang?
We're almost out of time, so.
Okay, that's great. We'll do 1 to 2 more, I guess. All right. So
Your stream was like 3 or 4 minutes behind. I don't know what's happening.
oh, that's fine. We don't
Or
worry about that.
anyways.
A block of 3.5 kilograms slides down a frictionless inclined plane of length 6.4 meters that makes an angle 30 degrees with the horizontal. If the block is released from the top of the incline, what's the speed at the bottom? All right.
I can't find the question. Where's the picture?
Well, I just said it out loud, but it's fine.
Yeah, my mental capacity doesn't allow me to keep up with that much words.
Okay, Ding. Okay. All right, I see how this is.
Where did you put the image for the question?
I don't know, man.
It's not on the doc.
It should be. If it's not, I'll just seppuku, I guess. Okay. First, finding the normal force. Or actually, not normal force, gravity, but same difference. Okay. 30 degrees. right, all right, all right, all right, all right. Okay, time is up. So this one's kinematics problem. Yep. We're gonna ignore how I'm still writing. We definitely gave enough time for all of these, right?
100%.
I know, right? So if you think you're too slow, don't worry. We're all in the same boat. We're not gonna worry about it. All right. Okay, so we need to try to find the speed at the bottom. So kinetic. Wait, we're going to ignore how I said kinetic energy. We're gonna ignore that. I'm just gonna ignore that. All right. So
I think there's a few ways you can solve this question.
yeah, there is a few ways you can solve this. It would be.
You can do the conservation of energy or the kinematics.
Yes, but I don't think they gave you the height, did they?
Well, you can calculate the height because it gives you the length.
Oh yeah, that's true. Yeah. I would use.
So whatever you find easier, you
Yeah.
can use, but you can use both.
Yeah. For kinematics, you would use one of the equations that has. Yes. You use one of the equations with, because once you find the velocity of the cheese or the block going down, you can calculate the speed. Well, it doesn't give you friction, so you can't use that method. But I think you would have to use kinetic
frictionless.
energy. Oh yeah, frictionless. We're gonna ignore that. We're gonna ignore what I just said. We're going to ignore that. We're gonna pretend it doesn't exist. Yeah, so it should be the same if you calculate it right. Velocity at the top and velocity at the bottom of the block of the incline. So should we do one more?
Oh, we're at 58 basically.
All right, let's do one more.
I don't think we have time.
The ball is thrown
Okay, never
straight
mind.
up. At what point does the ball have most energy? Okay, so we're going to kind of skip this. All right, Ding, do you want to explain?
I'm so trying. Okay. So when a ball is thrown straight up, at what point does the ball have the most amount of energy? So now you have to know that this is a system, and in a system, energy is conserved, or at least how what we're concerned with, energy is conserved. So
Yep.
Technically, the energy should be the same everywhere.
Yep, you are correct. And we're going to conclude it there because I don't think we have time for the last two. All right. So yeah, so we're going to put some practice problems that we found inside the folder on our website, so you guys can go ahead and check those out because we all need practice. You too, Ding, and you, Duff, you too, because you're just in the background sulking. Okay, I guess she's really just.
She's really gone. I don't know.
She's gone somewhere. All right, so thank you everybody so much for watching. Make sure you check out our website and our other notes that are on there, as well as resources. We do have. Hold on, what is that called? Spotify stuff? What's that called? Podcast. There we go. For you guys to listen to and enjoy. So, yep. There is that. I completely forgot the rest of the outro. So, Dane, do you want to take over?
Right, like I know how to do outros.
Yep.
If you enjoyed, make sure to like, and if you have any questions at all, you can join the Discord and ask us there, or maybe leave a YouTube comment. I don't think we might get to those, but I cannot promise you that we'll get to it immediately.
Okay. All right. Yep, but